Today, we are diving into a question that honestly seems so simple at first, but it can have these huge ripple effect consequences for your app's performance and, let's be real, your own sanity. It's a choice every single developer has to make at some point. So let's get right into the database dilemma.
So picture this, you've got a limited set of options for something in your app, right? Could be the status of an order, a user's role, whatever. You need to stick it in your database. The way you choose to do this can either be a total lifesaver down the road, or it can come back to bite you hard. So what is the right way to do it in PostgreSQL?
The first thing that probably pops into your head, and mine too, is the most direct path. We'll call it the simple string method. You just store the actual text. The status pending is just stored as the word pending. Makes sense. It's intuitive, it's fast to set up, but as we're about to see, it is absolutely a trap.
Now, to make this method a little more robust, you'd probably use a text column, and then you'd add what's called a check constraint. Think of it like a bouncer for your database column. It's just a simple rule that says, hey, I'll only let these specific words in, nothing else. And yeah, it works, it's easy to grasp, but it's hiding some really serious problems just beneath the surface.
So let's pull back the curtain on this so-called simple solution. Because as your application starts to grow, these hidden costs, they really start to pile up. And they hit you in two places where it really hurts: your storage space and your own precious time. What are we looking at here? 392 megabytes. That's the size of a test table with 8 million rows using that simple string method. Now, you might be thinking, 392 megs, that's not a catastrophe. But hold on. It's not about the number itself. It's a symptom of a much bigger inefficiency.
See, the real problem is just plain old repetition. Every single row has to store the full text of the status. Think about it. If your status isn't just pending, but something longer like awaiting customer confirmation, storing that long string millions and millions of times just eats up space. It inflates your table size for no good reason.
But honestly, storage isn't even the biggest headache here. This is where the real nightmare begins. What happens when your boss strolls over and says, hey, we need to change pending to awaiting approval? With the simple string method, this tiny little text change turns into a massive database locking operation.
Just look at the amount of work involved here. You can't just change the rule. Oh no. First, you have to completely drop the old check constraint. Then, you have to run a huge update command on every single row that has the old value. On a table with millions of rows, that is going to be slow. And then, finally, you have to add the new rule back, which forces the database to scan the entire table all over again just to make sure everything's still valid. It is painful, it is inefficient, and it bloats your table.
Okay, so if the simple way is so full of problems, what should we be doing instead? Let's meet the two main contenders for a much, much better and more scalable solution.
All right, on the left, we've got something called an ENUM type. The best way to think about this is like you're creating your own special data type right inside the database, a type that only knows about your specific list of values. Then on the right, we have the classic lookup table. This is a tried and true database pattern where you just make a separate tiny table to hold your statuses, and then you refer to them with a number, like an ID.
And right away, you can see the first big win. Remember our 392 megabyte table from before? Well, look at this. Both the enum and the lookup table slash that down to 338 megabytes. That's a pretty nice savings. And it's because instead of storing those long, clunky strings, they're both just storing small, efficient numbers behind the scenes.
Okay, so they're both way better for storage. But which one is the right one for your project? To figure that out, we have to put them head to head. Let's see where each one really shines, and, more importantly, where each one falls short.
This table really lays it all out. When it comes to things like storage, adding new values, or even renaming them, they're both fantastic, but you've got to pay very close attention to those two bolded rows. First, deleting values. With an enum, it's literally impossible. The feature just doesn't exist in PostgreSQL. And second, query speed. Enums are wicked fast, but lookup tables, well, they have a potential weakness that can really slow your whole application down.
And this right here is the absolute deal breaker for a lot of people. When you create an enum, you are making a permanent, irreversible decision. If you add a value like beta feature and then a year later you decide to get rid of it, you can't. You are stuck with it forever. I mean, sure, you can rename it to something ugly like deprecated, do not use this, but you can never, ever truly remove it from the type itself.
Now, let's talk about the lookup table's weakness.
When you write a query to find all the approved statuses, the database's planner, the thing that decides how to get your data, has a major blind spot. It knows you're looking for an ID, but it has no idea which ID belongs to the word approved until the query is already up and running.
So what? Why is this blind spot even a problem? Well, it's a problem because the database has to guess. It has to come up with a plan for fetching all your data without knowing if it's looking for 10 rows or 10 million rows. And a bad guess leads to a very bad plan. I mean, just look at this real-world example. The database estimated it would find almost 900,000 rows, but the actual number was only about 260,000. It was off by more than 500,000. This kind of massive miscalculation can cause the database to pick a super slow, inefficient way to get your data, and that can grind your whole application to a halt.
All right, we've seen the pros and cons. We have a rigid but super fast option and a flexible but potentially slow one. So how in the world do we make the right call for our specific project? Honestly, it really just boils down to this super simple decision tree. Step 1, and this is the most important one. Ask yourself, is there any chance, ever, that you will need to delete a status from the list? If the answer is yes, or even maybe, just stop. Use a lookup table. End of story. But if you are absolutely confident that your list of statuses is stable and will only ever grow, think days of the week, right? Then the ENUM is your faster, simpler choice. And finally, if your values are super short, like 2-letter state codes, and you know they'll never be renamed, that simple string method we started with might actually be good enough.
This whole dilemma just goes to show that even the tiniest design decisions can create these massive ripple effects on performance and, later on maintenance. So it kind of leaves you with the question, right? What other simple choices might be hiding in your own database schemas, just waiting to be optimized? Thanks for watching.